maybe more food for yourself if the group finds the food, or more access to potential mates. You don't have to compete with other individuals as much. So I'm just looking for something here as a benefit to not being in a group versus the benefit to being in a group, right? Not just saying, well, you don't have to be in a group. Well, why not? What's the justification for that? Okay, get back here. All right, Leptosterius is a sea star. Pisaster, sea stars, they both feed on blue mussels. We're going to remove the Pisaster and add Pisaster and have a control for the Pisaster and look to see what happens to the biomass of Leptosterius. And it looks like where you remove Pisaster, the biomass of Leptosterius goes up. Where you add the Pisaster, Leptosterius biomass goes down, whereas the control stays pretty constant. Okay? And the question asks, what's competition? So a lot of you said, well, competition is where two organisms compete. Don't define a word with another word with it. A lot of you put competition is fighting over a resource. Well, competition can occur without organisms ever coming in contact with each other. They don't need to fight for the resource. Hyenas and lions compete for gazelle, but if one hunts at night and one hunts during the day, then they would never come in contact with each other. So the best answer here is competition is an interaction between two species where the overall impact on both of these species is negative. Consumer resource is where one experiences a positive and one experiences a negative. Mutualism is where both species experience a positive. This is the best definition of it. Many of you went online and found definitions. Most of them I was okay with, but this is probably the best thing. That's what we talked about in class, and this is how it's typically defined. Figure out the impact on these two species. If it's negative for both, by definition it's competition. The sea stars both consume blue mussels. That sounds like consumptive competition to me. Consuming over a renewable resource because you can make more blue mussels. Do the results suggest competition? I'd say they do. Removal of the other species increases the biomass. Adding the other species decreases the biomass. If they're competing over a common resource, the effect on a species is negative, reduction in growth. Okay, all right. Gets us to the last page here. Interesting little fish. There's the mouth. There's the mouth on the other one. So there's the right mouth fish and the left mouth fish. Okay. Whether the fish is left or right mouthed is genetic. The fish that are pursued by these cichlids learn from their experience. If they've been attacked by a left-mouthed cichlid, then they spend all their time looking over their right shoulder. If they've been attacked by a right-mouthed cichlid, then the fish look over their left shoulder. So which direction they look is affected by their experience with these cichlids. Okay? You might expect that natural selection would remove both of these morphs from the population. However, both morphs have been in the population for many years, though the relative numbers fluctuate up and down. That's a little clue there. They both fluctuate up and down. Using what you've learned in class, argue for why both morphs would be expected to remain in the population. This is classic frequency-dependent selection. In frequency-dependent selection, the fitness of a morph is dependent on its frequency in the population. If the population is composed of mostly right-mouthed cichlids, the left-mouthed ones have an advantage because all the fish are looking over their wrong shoulder and I can sneak in and grab some scales. If the population is mostly left, the right-mouthed morphs have a huge advantage. Their advantage depends on their frequency. If I plot the two morphs over time, I would expect them to fluctuate up and down, but I would expect the fluctuations to be kind of like this. As the right morph is decreasing in frequency, the left is increasing. The right ones have lower fitness because the fish are used to them, because they're in such high frequency. Their frequency begins to come down at the same time the frequency of the left mouth cichlids begins to increase. Okay? The advantage to this individual here is because it's at such low frequency relative to the other morph. So the best approach here is frequency-dependent selection. Okay? I've posted the exam grades on Blackboard. I think most of you have seen those. Overall, very good. The average is around 90%, right? That to me suggests people put in some time to work through these questions. Keep it up. We just have the one final. I'll do the same approach with that one, a take-home exam. I'll give it to you a little early so that you can finish it by the exam period. Again, I'll take an old exam that's designed to be finished in an hour, but I'll give you extra time to work on it as a take-home exam. Don't be afraid. If I give you, right, information up here, don't be afraid to look this stuff up. It can add extra information above and beyond what you would normally have. I've given you enough information in the setup, but certainly looking up left and right mouth cichlids would lead you to frequency-dependent selection, and looking up this paper on sea stars would help, or looking up the stingrays would help, or looking up the scarlet king snake, etc. I added this information in here so that if you wanted to, you could look it up for extra information. You don't have to, but if you're stuck on these questions, not really understanding what's going on, it wouldn't hurt to take a peek at them and see what's going on. Okay? All right, I'm going to go ahead and break things right now so I can reset to a different configuration. I can put the screen up here and work with the whiteboard. Okay, so I'll see you on the other side.